All right, Algebra 2. The next lesson here, 2.4, is about writing linear equations. Hey, you guys have done a lot of this in Algebra 1. We're going to introduce a little, well, I don't even think it's a new introduction. I think we've done this in Algebra 1 as well, but we're going to remind you about the various ways that we can write linear equations today. So the first one is the one that we should be super familiar with, and that is the slope-intercept form. This is the one we spend most of our Algebra 1 time together working on. Okay, so just to review, that is the y equals mx plus b form, in which m is just a number that represents our slope of a line, and b, for some reason they used a b, I don't know why, is the y-intercept. Okay, so they used b to represent the y-intercept. So again, if I have something like y equals 2x minus 3, if I'm going to go to graph that, I always start, if something's in slope-intercept form, I like to start with my y-intercept. So at negative 3, I have a crossing. My slope from left to right is positive. It's going up 2 over 1. Up 2 over 1 puts me there. Up 2 over 1 puts me something like that. So I got this line like this, right? So just a quick review on slope-intercept form. If I keep going here, it says write an equation in slope-intercept form for the line that is described. Okay, they give you a slope, they give you a point. Okay, we did do this in Algebra 1, but let's review this again. So what you're going to do is, if you're going into slope-intercept form, and I haven't taught you point-slope form yet, but I will, what you're going to do is you're just going to start with that form. Y equals mx plus b, and you're going to plug in the things that you know. Okay, you know slope, and you know an x value, and you know a y value. All right, so I'm going to plug those things in. The y value that is given to me is 4. So 4 equals, slope is 4/3. 4/3 times x, 0, plus b. So I'm going to plug those things in and I'm going to solve for b. Luckily, this thing just goes to 0, right? So I'm just left with b is equal to 4. Okay, so now once I have my b and I have my slope, I can go back to this equation and plug in the things that I now know. So it's always going to be a y equals, we should now know m was given to us 4/3 x plus b. The b we found was 4. Okay, so there's your equation in slope-intercept form. 1b makes you go through one more hoop, okay, because they give you 2 points. You guys should be able to find the slope of a line that goes between any 2 points. If that's a stretch for you, I will review it here. It's just the change in y, right? The difference of the y's over the difference in the x's. Change in y over change in x. So here, I don't know if you guys can see that okay. Zoom out a little bit maybe. Anyway, that's a 10 over there. So what I'm going to do is I'm going to plug in y2. Okay, so I'm going to call this x1, this y1, this x2, this y2. Okay, so if I plug in my y2, it's 10 minus negative 6. Okay, don't forget that's a minus a negative there. And then my x2 is negative 4 minus 0. Okay, so I just got those from the points. When I do this, I get 16 over negative 4, which is equal to negative 4. So my slope, or my m value, is negative 4. Okay, now I'm going to use a point. The point I'm going to use is this one because I like this 0 here, and I think it's going to make things easy. So we're going to go back to this. We're going to go back to y equals mx plus b, and I'm going to plug in the things that I know. I know a y value, it's negative 6. I know a slope now, which is negative 4. I know an x value, which is 0. And I'm trying to find b. Okay, this just goes away, so it's just b is equal to negative 6. So therefore, my equation will be y equals negative 4x minus 6. And I am all done. Excuse me. So that is example 1, slope-intercept form. Now I'm going to show you a little bit of a shortcut of how to do some of that with point-slope form. So whenever you're given a point and a slope, point-slope form, you can actually plug it into this guy. Okay, so and actually, if you're going to go on to like pre-calc and calculus, they actually prefer this form over the slope-intercept form. So let's review this. We did do this in Algebra 1. Let's review this again, though. So it's y minus y1 equals m, which is the slope, times x minus x1, where y1 and x1 are just coordinates, a coordinate that you know, right? So if you have a point, let's just say it's like 2, 3, okay, and we know that, and let's just say they give us the slope that m is equal to, let's just call it 2. Okay, how I would plug this information in there is I would just say, okay, y minus the y value, which is 3, is equal to the slope, which is 2, times x minus the x value, which is 2. Okay, just getting that from the coordinate. You could, if they want it in point slope form, that's it, you're done. You can leave it like this. If you want to, though, you can easily now convert this to to slope-intercept form. The way that you do that is you just simplify it, right? So if I were going to do that, I would have y minus 3 is equal to 2x minus 4. I just distributed, right? And then I'm just going to add the 3 to both sides. So I get y is equal to 2x, what is that, minus 1. And voila, I have just transformed that thing into slope-intercept form, right? So when you simplify point-slope form, you just get slope-intercept form. Okay, so example 2 says we have an equation. It says to just write it in slope-intercept form. So they're not wanting you to simplify it at all. It's very simple. You're just going to plug it into this guy. Y minus y1 is equal to m times x minus x1. This is worth memorizing, you guys. Definitely spend some time with that. So if it passes through 2, 3, that's my y and my x, right? So I have y minus 3 is equal to my m value, which is a half, times x minus 2. And they want you to just leave it like that. Okay, so you're done. That is your answer. Then for this one, let me see if I can find out what that value is. It's negative 3. There we go. Okay, so y, so here it's minus y minus negative 1, which is really just y plus 1, right? Hopefully you guys caught that. If we're subtracting a negative, it's just addition, right? Is equal to negative 3 times x minus negative 2, which is just plus 2, and you're done. So this is really just very simple. You're just plugging these things in to slope-intercept form, and you can just leave it, and it's very nice and easy, which is why we like it in calculus. Example 3 says, which is the equation of a line that passes through these 2 points? Well, to find that, I first need to find my slope, right? So to find the slope again, y2 minus y1 over x2 minus x1, and just plug in the things that we need to plug in. So y2, let's call it negative 4. Negative 4 minus negative 9 over 2 minus 4. That is equal to negative 4 plus 9, which is 5, over 2 minus 4, which is negative 2. So the slope is negative 5 halves. Right away, I have eliminated these guys. Okay, so now I got to figure out what the b value is. So I have y is equal to negative 5 halves x plus b, technically. To figure the b out, I'm going to choose a point and plug it in for the x and the y. Okay, so the y value is negative 4, so I can say negative 4 is equal to negative 5 over 2 times 2 plus b. Okay, when I do this out, I get negative 4 is equal to negative 5 halves times 2 is just negative 10 over 2, which is just negative 5 plus b. Okay, so then b is equal to, if I add 5 to both sides, 1. And it's positive. Okay, so the only one that matches would be this guy. All right, so that's example 3. Real quick, guys, we're going to talk about parallel and perpendicular lines, and then we'll do an example, and then we'll be done. So parallel lines, all you got to remember, you guys, is it's the same slope through different points. Okay, so if I have y equals 2x minus 3 and y equals 2x plus 5, these are parallel because we have the same slope, different y-intercepts. Okay, so I can identify that right off the bat. For perpendicular lines, you know that they're perpendicular if you multiply the two slopes together and get a -1. So it's always going to be a flipped, switched slope. So we talked about flipping it and switching it back in Algebra 1. Hopefully that clicks with you. These guys would be an example of perpendicular lines because this has a slope of 3, this has a slope of -1/3. -1/3 is 3 over 1 flipped, right? So it becomes 1 over 3, and then switch the sign, negative. Okay, so remember that a perpendicular line is going to, if you think about what that is, you know, if you have something that's perpendicular, it's going to meet at a 90-degree angle. So this makes sense that the slope is going to switch both magnitude and direction, just flip and switch in order to get this 90-degree angle every time. Okay, so notice this angle, or this line here is positive, the slope of this line here is negative, and that will always be the case for perpendicular lines. So their slopes are always flipped and switched. So example 4 says, write an equation in slope-intercept form for the line that passes through 3, 7 and is parallel to the line with the equation y equals 3/4 x minus 5. Okay, so real quick, guys, last one here, hang with me. This is y is equal to, I know that if it's parallel, I know my slope would have to be the same. So I'd have to say 3/4 x, but this is not the same. So that's what we're really trying to find. So we can say plus b. Okay, we know the coordinate that it passes through. Therefore, we can plug it in. So my y value there is 7. So I can say 7 is equal to 3/4 times my x value, which is 3, plus b, and solve for b. So 7 is equal to 3 times 3 is 9/4 plus b. Okay, so if I move my 9/4 over, this isn't super easy. You can also think of, there's a couple ways you can think about this, but 9 over 4 is the same thing as 4 goes into 9 2 times. It's like 2 1/4. So if I add 2 1/4, if I have a positive 2 1/4, I got to subtract it from both sides. So if I take 7 minus 2 1/4, that will give me 4 3/4, I believe, right? Okay, so my final answer, y is equal to 3/4 x plus 4 3/4. The other way to do that would be to find a common denominator of 4 by changing 7. You can write 7 as 28 over 4, right? And then we could subtract the 9/4 from that. And if we do that, we get 21. Sorry, not 21. 19 over 4, which is the same thing as 4 3/4. Anyway, a couple of ways to look at that. So that's all for this time, guys. Have fun with lesson 2.4, writing linear equations. Hopefully this is mostly a review. See you guys next time.